All right, we're going to factor this one. We're gonna start looking for the GCF because that's the most common approach. GCF. We would always look for that first whenever possible. Okay, so I'm going to look in here. First thing I notice is I will look at these coefficients and determine if they have any common factors. And you can think about your times tables to decide. The 33 I know can be divided by 3, so can 18, so can 9, and so can 12. 33 is kind of odd because it's only 3 times 11. So it looks like 3 would be the greatest common factor for those coefficients of each term. So that'll be part of my GCF, and I'll have a 3. Now, to get the variables, if there are any common, first see if there are common to each an x. Notice you have x third, x fourth, x third, and an x fifth. So x is common. So you would want to take an x, and what you'll do is you'll look for the lowest power of any of the x's that you see here. And the lowest power looks like it's third power. So that's the greatest common factor is x to the third for those variables. Now, so that takes care of the x's. Now, do the same thing for the y. And same thing on the y's. This one, this one, this one, this one. First, make sure they all have y's. And second, pull out the lowest one. So this is the lowest one right here. Y to the second power. So that's what you're going to take out. You're going to have y to the second power. Then you do the same thing for the z's. Like this one, there's one here, there's one here, there's one here. So there's a z factor in each of the 4 terms that I see here. That means I can pull out a z. And the next question is, what power do you want to pull out? And you should be asking yourself, what is the lowest power of any of those z's that you see up there? You see z5, z3, z4, z3. So the lowest one is 3. So that means that's what you'll pull out, 3. Okay, so now that is the GCF. If all you wanted was that, you could stop there. But if they're asking you to factor it, then you'll write this as equals, and you'll put parentheses over here. And we're going to fill in the blanks here. So now when you're factoring, you're essentially dividing. You're dividing out the common factor that you have here. What's left over? Well, we're going to do some arithmetic to look at this, the arithmetic of the exponents to get us to the answer. We're not going to do a long division on each one of these, or even any kind of division. But essentially, we are working with factors and therefore division. So we're going to do, first of all, 3 times, I'll do this and go over here, 11 makes 33. Okay. Now, the 18, that would be a minus 6 for the 18. And the 9 would be a plus 3. And the minus 12 would be a minus 4. Okay, so that takes care of the coefficients, numerical coefficients. We've got all those in place. Now, x to the third. Well, you want this to be the result when you multiply. Well, I already pulled it out, so I don't need any more x's in here. Right here, I don't need any more x's. Now, I do need a y to the fourth to turn out. I only pulled a y squared. That means I need another y squared, because y squared times this y squared makes this y to the fourth. Okay, I need to end up with a z to the fifth. I pull the z third. That means I need a z squared. Okay, and you can double check your work. You just have to do a quick mental arithmetic. X to the third times times all of this just makes an x to the third. Because there is no x to the third over here. There's nothing over here. Y to the second times y to the fourth. Sorry, y to the second times this y to the second makes y to the fourth. Z to the third times the c squared makes z to the fifth. So you're just doing this arithmetic with these exponents to make sure that they add up after the multiplication takes place. Okay, move to the next term. We need an x because to get that x to the fourth, you'll need 3 plus 1 is 4. You'll need one extra y to make a 3 here because you already have 2. An extra 1 will make the 3. The z to the third, well, I already pulled that out, so I'm done. Done with this term. Next term. Now the 3, I need an x to the third to result. Well, I already pulled that in front. I need a y squared to result. I already pulled that in front. I need a z to the fourth. Well, I got a z to the third. That means I only need a z here. That takes care of that. Next one, finally, we need an extra x to the second power because you have 3 up here. 3 plus that 2 makes a 5. And you also need y. We need y to the fourth. We pulled y squared. We're going to need another y squared. We need z to the third, but we already pulled out z to the third, so we don't need anything else. Close it up. And it's done. That is completely factored. We got the GCF. So it's kind of like 4 problems in one. But and it is the reverse of multiplication. So if you did the exercises in multiplication, then these should be it should be okay. You're just working backwards. It's the opposite of multiplication, factoring is. So, okay.